Hello, everyone, and thank you for listening to the Fabrication Friday podcast. I'm your host, Joe Fairley, certified prosthetist, 3D printing enthusiast, and owner of Ascent Fabrication. Fabrication Friday is an all-around fun time where I talk about 3D printing applications, conduct interviews with industry leaders, and much more. Come join us every Friday for an informational discussion around the evolution of the additive manufacturing field and how we utilize various digital workflows and 3D printing methods in our daily work at Ascent Fabrication.
Thank you very much, everyone, for tuning back into the Fabrication Friday podcast. I'm your host, Joe Fairley. Today, I am with Fedor Antonov of Anisoprint. He's just corrected me on the name pronunciation, which I am very thankful for. And really want to touch on a few very top of mind topics that are apparently both on Fedor's mind and my own with Ascent Fabrication and getting into our work at Proteor as well for 3D printing prosthetics. We are really going to focus today on the topic of design for additive manufacturing, DfAM. So without further ado, Fedor, thank you very much for coming on the show today.
Sure. Thanks, Joe. Thank you for having me. Hi, everyone. I'm really looking forward into this discussion. And let's see where we can end up with this discussion. So I have lots of thoughts, lots of ideas. I don't think everything will fit, but let the conversation flow and see which kind of topics we will have time to touch.
Absolutely. We could probably talk for 3, 4 hours on this type of topic, I'm sure. We might just go
Definitely.
right into the weekend here, but no, we'll keep it a little brief for those that only have maybe a 45-minute or hour commute to work. But so getting on this topic of design for additive manufacturing here, Fedor, this is the reason I reached out to you a couple days ago. One of your LinkedIn posts really resonated with me, that you were describing kind of some of your similar interactions with customers that you are having at an Isoprint, doing continuous fiber 3D printing for manufacturing in true production status, right? So you say here, if the part is not designed to be 3D printed in production, it will not be 3D printed in production. And if you want to implement 3D printing in production, you should start with the design and evaluation like every production technology. So, that little bit right there, I think speaks volumes to this concept of, we need to be designing our devices around the type of manufacturing process we're using. Could you elaborate a little bit more on your statements there and kind of how do you approach one of these customers when they come to you with a part?
Surely. So this is to me this is kind of obvious thing, but I think I will get to it in a like second part of my answer. As long as you mentioned the design for additive manufacturing, and before we started, you also mentioned that it might be interesting for the audience to hear how we actually started up with the company and with the idea of continuous fiber. And when you mentioned, and then you started with this, but actually this is what was the main motivation. This was the exactly why. This
Mhm.
was exactly the reason why we started the company 10 years ago. And I would like to start with this because then it will help me uh, to
Absolutely,
answer your actual question. So
for sure.
uh, um, I was a scientist. Yeah, we were working in a research lab and a research institute on composite materials. And we had a team, we had a group, which where we focus on what they call like unconventional composite designs. So conventional composites are like laminates and sandwiches, right? And unconventional are something what they call fiber steering. So is when the fibers are not placed like are not put like on a like straight layers, but they rather follow like a curvilinear trajectories. And then we were also doing what they call lattice designs with composite materials, which also has a very long history. And then we were also doing what we mostly did was trying to explore like new design approaches for composite materials. I've never done 3D printing back then. It was like 2013 when we were doing that. But we start experimenting with generative design, topology optimization, and we came up with some mathematical approach for generative design of anisotropic materials, basically composites. And the designs which we were getting as a part of our study were so unconventional, and there was no way you could really make this kind of designs with traditional composite manufacturing technologies. And then we thought, okay, but how do you make it? How do you make it in real world? And then we start looking. Yeah, there is no such hardware technology. So we thought, okay, let's try to invent it. And then we start exploring the way. So we needed to find the hardware technology which will give us a full control of the fiber placement trajectory. So we needed to be able to like fully control the direction, the trajectory of the fiber, hence the material, that directionality, the material properties, directionality in every point of the structure. So that's what we wanted. And then we realized that you can do it through 3D printing actually. And then we start trying, and then quite quickly we got a very good results, very exciting results. And then we said, okay, that's so fun, that's so cool. Let's try to develop it further and make a product out of it. So we started with the understanding, with the fundamental understanding that the technology, the composite manufacturing technology, is limiting the design capabilities, is not allowing to make the best designs. And then we came up with such designs, but there was no technology. So design and technology are always interconnected. So you cannot. I worked personally as a design engineer, as a stress engineer for almost 6 years, and I talked to experienced engineers a lot, and I've seen many parts which were designed for production, and I've never seen that the part was designed without a specific technology in mind. This
Right.
this is never
Right.
the case. When the engineer first comes up with a principle like schematics of the system, then he breaks it down into the interconnected parts, and then he looks at each part, and depending on its complexity, its purpose, he, out of his knowledge, out of his intuition, out of his experience, he would first of all determine what kind of technology could um, could fit there. And yeah, if it's sheet metal, if it's like something which like has like surface kind of thing, then he would obviously go for a sheet metal, right? Or if it's a very complex like shape and all that, then he would probably go for milling.
Hmm.
And this is what, and this is the original assumption of an engineer. And then when he makes this assumption, the design, the whole like life cycle of the part goes through so many steps, and then it has to be proven, it has to be verified, it has to be like simulated, it has to be updated many times, and it has to be tested and approved, and then when it
Hmm.
goes to
Right.
production, it has you cannot simply change anything when the part is already in production, because you cannot make sure that the changes you make, even it's if you change the material or if you change the technology, if you change the technology, most likely the geometry will change. There is
Sure.
no one can guarantee that the part will still function as it was supposed to do. So
Hmm.
this means that each part is not just a 3D geometry, or it's not just the blueprint and where you can easily change something. Yeah, it comes with a certain assumptions. It comes with a certain uh, uh, validation and verification and many
Hmm.
other things.
Right.
And it's always it's all these parts. Yeah, so the design, the technology, and the material are always go together
Right.
for each thing that you have in production. And I think in like industry, like in manufacturing, everyone understands this. And but the problem which we have with 3D printing, I do not know whether yeah, 3D printing originally was basically uh, prototyping uh, technology.
Right.
Uh, this is how it was established for for decades. And for prototyping, yeah, prototyping, it doesn't matter. Yeah, if you want to make a prototype, you just need a way to make all these things which I just mentioned about the production piece.
Hmm.
It doesn't apply to a prototype piece. So for a prototype piece, which you may use for like the purpose of like fitting and check like assembly fitting or um, uh, something like this, you may not care about the technology and the material, because in the end there will be a different one, yeah, the one that you designed it for. So the attitude to 3D printing was
Hmm.
that this is the technology which can make anything with some crappy materials, can make you anything, so for the fitting purpose, but obviously this is not a real thing. And it's but then the industry realized that if the industry want to get bigger, the prototyping segment is just not big enough.
Right.
Uh, and the I saw this happening like in 10 years ago, this that the industry was shifting. uh Still like 10 years back, you could still hear this like rapid prototyping. Now
Right.
you never hear 3D printing to be referred as rapid prototyping. But still these habits, I think these habits still remain in the customers' minds, and uh, uh, they still most of the customers still have uh, either a very limited experience with 3D printing,
Right.
or this experience is only in prototyping. And this probably creates also this like misconception of a 3D printer as a magic box, which can make you anything out of anything,
But that's what a
which is
3D
not true.
printer is, right? You can't just put your part in and it doesn't come out, perfect every time. What do you mean, Fedor?
Unfortunately, no. But yeah, this is more or less true for different 3D printing technologies, because 3D printing is huge, and it's dozens, if not hundreds, of different technologies, and definitely hundreds, if not thousands, of different materials.
Hmm.
And this like magic box concept is maybe more valid for like a powder bed, or like SLS or like SLM, uh, or resin like DLP, SLA technologies, but it's definitely less and less valid for like FDM. For continuous fiber, it's absolutely not valid. So each technology has pros and cons, has limitations, has constraints.
Hmm.
Um, and I think that 3D printing should not be looked at as the magic box that can do anything. The best use cases, and
Hmm.
I would say the only real use cases, are the use cases, are the parts which are impossible uh, other ways. Yeah,
Right.
with all these like rocket engines with complex cooling channels inside, and you cannot do it other ways. And so that's why you have to start with DfAM, right?
Yeah, with
Uh,
that kind of DFAM approach there, where we really need to focus on the application that we're going to be focused on, the materials we're using. And you mentioned before the show here too how you could have one single printer designed for a particular purpose, right? That, there's not just this magic box concept of you put a part in
yeah.
and it's going to come out perfectly, but going
So
one step further than that, that we're actually maybe then going back to the drawing board and designing some printers specifically for a purpose that has the perfect build volume for the thing.
yeah.
It has the right hardware, maybe it has a heated chamber or whatever, but that you have that one purpose in mind for that particular part that you want to print. So how do you translate that into kind of
Yeah.
what your ideals are there at an isoprint, and why continuous carbon fiber for that purpose too?
Yeah, so we start realizing this more and more, and I think it's it's a big problem of our industry, is that there is too much focus on, no, I would say not enough focus. It's
Sure.
we were so obsessed uh, initially with this concept of magic box.
Hmm.
We were so bound to this like versatile machine, which is one suits all. And this obsession created in technology developers, in OEMs, the obsession over characteristics rather than or around applications. And I've heard this from someone from the industry. I think this is really shows the problem in the industry. So imagine you've been to Fornext, yes, this time. I've been there like for 7 years in a row. When the customer who just wants to start with 3D printing, he has he wants to learn and to understand what are the options
Hmm.
available. He comes to Fornext, and confu- what a confusion is it for the customer, right? So he sees each vendor claims his machine is the best. It can do anything, but now this machine can do anything and it's $200. This machine can do anything and it's $2 million.
Yeah,
What these numbers, uh, millimeters per second, and all these like characteristics tell can yeah does ring a bell for him. He wants to see how these machines can solve his problems, and every vendor claims he can, and every one tells that his technology is better, and then he just get and
yeah. I mean, where do you
that's
start? Even in a place like
yeah. Where
Formex?
do you start?
Yeah,
Where do you start? And but the we should face customers, right? And we should help customers to understand the real value. There, you cannot fake value, right?
yeah,
Uh, you can lie to your customer, but then you will you will maybe sell a machine, but then you will get an angry customer.
sure. Yeah,
So it does make sense.
yeah,
You need to have a real value which the customer will understand, and the reality is that uh, for most of the cases, this value is can only be unlocked through design, through unique designs that other technologies are not capable of.
right.
So, and that's why the customers typically, uh, how do you approach? Imagine you being an engineer, like working on some product. How do you approach this? Uh, you don't know how to design for this technology, so you cannot come to the technology provider with a design that is ready for his technology, that because you
Right.
don't know.
Right.
So
I
the
mean,
only
I
way
don't know the
that
first thing about
yeah
injection molding,
yeah
but
you don't know
it's going to be
yeah yeah
certainly a different design
you
process than what we're going after here.
yeah you have to start with something. So then you normally what they do, they already have some design which obviously not uh, the design for this technology he wants to implement, this like 3D printing technology he wants to learn about. It's some random design, let's say for milling or for something else. But then the vendor, yeah, the technology provider should uh, go into this conversation and explain. Okay, now I see the part. Now we need to sit together, make a few steps back, start from constraints,
Hmm.
design space, load cases, requirements. And then starting from there, we will help you to came up with a proper design. And then only if you have a proper design, you can benefit from this technology. And unfortunately, most of the customers give up at this point.
Hmm. Right.
Uh, they think it's there might be different reasons, and one of the main reasons is of obviously lack of education and knowledge. Of course, he's afraid because he wants his engineers, his team to understand what they're doing,
Sure.
and they're not trained. They don't know. This is something new for them. It's a huge risk. Why would you trust some guy who wants to sell you something, and your own team have absolutely like no understanding?
Right.
Uh,
Yeah.
and yeah, this is one problem. Yeah, they don't know and they don't trust. They are scared. Then they have no experience. They have no success stories. They don't know how it works. They don't have yeah, they don't have their own production capacity. So they may have some machines in house, but
Right.
they have experience with. They don't probably even have. So it's a lot about like building this knowledge and trust and supply chain, and which basically means that uh, you need to mm, uh, deep dive into this journey.
Absolutely. Yeah,
Uh,
you're putting the whole
and
package together for them.
yeah, that's
It's
the whole
everything.
package. Yeah, and you need to really spend much more time and get much more engaged with the customer and show them that you are here to help and prove that, and and it's a long term. It's not. It may take a few years.
Right.
Uh,
Right. Yeah, I think that's
and
one thing I really want to point out here is that the amount of time that it does take sometimes to just develop a product from an idea to a prototype to something that can be end produced. Companies
Mhm.
take years and years sometimes to
Yeah, yeah,
finalize design concepts and testing as
and
well. And that's one thing that we've seen at Ascent Fab is
I
that,
can tell you.
yeah,
Sorry for
that's okay.
interrupting.
Go
This is
for
just one thought that I really like
it. Yeah.
uh, about 3D printing is that it can actually as being a rapid prototyping, but it can actually eliminate prototyping. I can tell
Yeah.
you why. So as a hardware manufacturer myself, I make these 3D printers, right?
Hmm.
I know from my experience that the one of the easiest thing is to make a prototype. Prototypes are so easy, and the gap between the prototype and production is huge. It's a huge gap,
Right.
and because of this gap, uh, most of hardware startups fail because it's so easy to make a prototype. It's so easy to get excited about how cool your prototype is,
Yeah.
and then you want to deliver it to the world, to your customer fast, and you are so excited. And you promise in 1 year, thousands of happy customers will get it, and then you face the reality of production,
Hmm.
and then it's 1 year, second year, third year, you got bad quality, you got unhappy customers, you got delays, and you fail.
Hmm.
Uh, and one of the reasons behind this gap is that you use different technologies for for prototyping and for production.
Right.
And before you actually go into real production, it's especially if you don't have much experience, right? And this is mostly the problem of a startups, but the startups are it's where innovations come from. So this the the presence of this gap is a huge barrier for innovations in hardware, because innovations are made with startups, and startups typically underestimate this gap. And the fact that with 3D printing, it doesn't matter. You can both prototype and mass produce using the same technology. So you actually learn more about the technology while you're prototyping. You learn more about this capacity and capabilities, which helps you to set up production, and it helps you even in a more like flexible way. It's a learning curve rather than a gap.
Right.
And so this is where 3D printing can really help, and can really grow from, right? So I had this idea, and I can explain you why I think it still doesn't work, unfortunately.
Yeah.
So yeah, you have uh, uh, big companies, right? Big companies who know what they're doing all the time. They have production cycles. They have everything like running. They can uh, make new products like every month, like launch like new products every month. But they will never adopt 3D printing at scale. It will be so hard for them, because all the processes in these companies are very rigid. Uh, each company has the design DNA, the design heritage. Is like, I know that in Boeing they have this Boeing design manual, which is uh, 3,000 pages book written back in 70s, and it's a Bible. And
Right.
no one can do something if it's not compliant with BDM. And each company has a lot of this design heritage, and it's very hard to implement things that are dramatically different,
Right.
which has a different approach, because it's basically then, to do this organization will have to break their backbone, and
You've got to get around some
re
red tape, maybe at that point.
yeah. And 3D printing, I've also gone through this. The problem is that it's fairly easy to sell to these big corporations. You can sell a few machines, but you sell them to their innovation departments. And
hmm
innovation departments are basically a group of like guys who are like playing toys. And even if the innovation department is successful, they've proven some business cases. They they've done great job to prove that this new technology should be implemented. It's very hard for them to sell it internally,
hmm
and it will just stop internally. So then the idea then is, okay, then you go to this like startups, right? And you talk to them and you try to help them, and they're more open. Yeah, you help them with the design, with the initial stage of the design. Uh, if they're successful, if with your help, and they start scaling, they'll start buying from you more and more to scale their production. Yeah, so it seems like a very good approach.
Hmm.
uh, but uh, the the problem, the reality is that unfortunately startups, uh, I've never seen, I can't bring you the case where the startup is like just about uh, mechanical parts.
Hmm.
Yeah,
Right.
so each product has something, like, imagine like a humanoid robot, right? The one of the last things the humanoid robot startup will think is hardware.
Yeah.
They will think about like controls, AI, batteries, motors, but the mechanical part is always something least important.
Right.
And as a startup, they also have to focus on their own innovation, on their own thing, and they just don't have time to. They just say, okay, this is not so important. We'll just do it the old way.
Right.
Why would we also have a risk here? One more risk here, and so that means that this like further limits our options to the use cases where the mechanical design is the real key, is the real value. And there uh, there are such cases. They're quite rare,
Yeah.
but they do exist, and they exist a lot in sports.
Hmm.
Um, and probably in healthcare.
Yeah, maybe for some of those
So
more custom applications that we were talking about before.
yeah. So and for and then if you working on if you go on this way, yeah. So what you need to do is sit with the customer, look at his designs, pick the parts that you really believe would make a difference when they're made with your technology. Let's say we're talking of
Sure.
continuous fiber printing at the moment. So uh, you would never be able, at least at this moment. So there is probably no such single technology you can make everything. Yeah, each
Right.
technology has
Right.
its own like scope where it works better. So you would pick some parts, you would design them, you would test them, then you would need to look into the economics, then you will need to optimize. And for 3D printing, it's really important that you pay attention to how do you optimize speed,
Hmm.
how you
Right.
optimize mm, quality
Well,
and
that's the
stuff, how
whole other
you
side of the
optimize
discussion.
material costs.
Yeah.
And at this moment, uh, your goal is not to like sell like one machine, or like my goal as OEM is, uh, if I invest in this like my time, my team time in this like long lasting conversation, then my goal would be to sell like 100 machines. And this is where this is justified for me, when I make sure that this runs in production. This runs at large volumes, and large volumes require a large number of machines.
Right.
And in this case, I might want to like tune my machines so they would be a better fit for these applications. That they will do like certain motions like faster, but certain mechanics that would allow like faster motion, like faster change or something like
Right.
changing print heads, like changing nozzles,
Right. Yeah, I think that
and
concept of, design for additive manufacturing doesn't just stop at the design of the part itself, right?
yeah,
It's
yeah, exactly.
how does a material behave when it's coming out of the nozzle at a certain temperature, right? It's all the slicer
Yeah,
settings that
yeah,
we're developing in order to make sure that they print consistently and reliably too.
yeah,
Because
yeah,
it's one
and
thing to just get one nice print out of a out
mhm.
of a printer for, that particular design, but can you do it effectively,
Yeah, yeah.
with reliability too?
Actually, yeah. So the thing is that there are tons of parameters. There are tons of settings in each machine and each process, and fine-tuning the settings for particular part is the key to successful prints.
Yeah.
So we
And which
have
could take
normally,
months,
yeah,
months up to years
yeah,
to
yeah,
really fully
yeah,
develop, right? I mean, have you
yeah.
seen some of
S-
those examples with some of the customers you're working with?
Definitely. So sometimes it takes you uh, 20 attempts for the first successful print.
Right.
And
Yeah.
but then every print after is successful. Some may fail, but you still keep improving. And then after this like effort, so it's actually hard to make a first print successful. So first print from is, especially if it's a complex geometries, yeah, it depends on the geometry of course. So first print may be like 50% successful, and but then like tens and subsequent prints are like 99% uh, successful after you tune everything, after you find all the bottlenecks, after you identify all the bottlenecks in this design, and resolve them.
Right.
Then so this again, right? So this is uh, uh, this pays back only if this then goes into large volumes, and then this goes into production. And this sort of probably goes a little bit in contrast with this idealistic concept of a magic box.
Right.
But this is the reality. This may change later because, yeah, especially with AI, when we have enough data. Currently, we don't have data. We
Sure.
don't have much data to be able to uh, do all these iterations virtually.
Sure.
Uh, Maybe later, when we have enough data, we will have every first print successful. But still, not we still are too small to be able to afford that. So I think for uh, many use cases, it makes a lot of sense to narrow the capabilities of the machine around this particular case to make
Hmm.
sure that this case works better, faster, more reliably.
Right.
Uh, and yeah, so this obviously also goes with design for additive manufacturing.
Right. Yeah, again, it's not just about that design, but can we fine tune the printer settings? Can we have the
Mhm.
right hardware onto the printer for that particular part? Do we need to swap out nozzle sizes or even a material for the nozzle that would make it more
Yeah,
reliable
yeah,
over time? Whether we're using, again, I'll just use a desktop example of brass versus stainless steel, right? Or
yeah, yeah, yeah.
getting more into some of the exotics of tungsten carbide, with how we can see sitting down with the customer initially and looking at their part
Yeah.
and not only going through those thoughts about, okay, how is this part going to be used in your short term, and where would you like it to become into production status? Because again, I think that we're finding with more of these, better slicing techniques, better machines, better materials, and just more ways of understanding how we can put all this together. This is how we're truly taking the rapid prototyping side of 3D printing into production,
Mm.
right? So I mentioned earlier, with some of the work that we're doing in prosthetics, we're truly coming up with end use parts that are going to be certified for, years of use. So it's not just that we're able to go to the prototyping stage and maybe then go to a different technology, but now we're starting to utilize 3D printing for production. And
Hmm.
I think that has a whole nother set of considerations, right, around like the supply chain issues or the production lead times for scaling that process up. So, I've got a one customer
Exactly.
right now that I'm working with on, his one part, but then he wanted to know, what is 100 parts going to cost and what's the lead time of that? And what are then the considerations around when do we add on a second or a third or 50 printers in order to
Hmm.
speed up this process? And, what does that development time also look like? What kind of space do you need in order to have a true production, uh, in-house? And I think I want to touch on that as a question for you. Do you see some examples where this scaling to production is actually not suitable for that particular customer in-house, where they might still be able to have production supported by a third party because they themselves either might not have enough personnel who are truly trained in 3D printing to be able to handle that kind of production and know that technology very intimately, or have you seen that in some examples with what you're doing at Anisoprint that maybe it is fairly simple for some companies to, of course, adopt everything in-house?
It's a very good question, and I think it has uh, again different aspects. Scaling, scaling production, right? And this is the one of the biggest barriers for 3D printing because most of the businesses want in the end they want to justify their costs. Yeah, they need large volumes,
Hmm.
and the traditional paradigm is the gigafactory, right? When you have a one big, when you have to invest in a one big plant with a conveyor belt and a bunch of like different technologies where you produce like millions of like parts and products and then you ship them all over the world. And this is obviously not the approach, the paradigm where 3D printing will work. Because 3D printing is, as I would say, as I say, essentially non-conveyor.
Hmm.
So the conveyor technologies are very specific steps with very short cycles.
Hmm.
And 3D printing is like mostly from nothing to the final part, but a very long cycle.
Right.
Yeah. And so this brings the from this brings us from gigafactories to microfactories. So the scaling now can go linearly instead
Hmm.
of uh, um,
Exponentially then.
with
Yeah.
so it's like in a tradition you need to like make a one big jump, right? Like to from zero production to like millions.
Hmm.
uh, this is the gigafactory, so it's like a gap. And with microfactories, you can add up like more microfactories in different territories you want to sell. And then in this case, the microfactory is like the next level of 3D printer, right? So if it includes both the hardware and the process, all the hardware knowledge, all the process knowledge, instructions, right? So that if you can design a microfactory where any workforce can like any like graduate engineer
Right. How specialized do you
or
need
even
those people to
or
be?
yeah, or even worker can just work. So then you are now you can start selling these like microfactories, and not even as a technology OEM, but as product OEM. Imagine like you are a car manufacturer. So as a car manufacturer, you are manufacturing cars and then you sell them through dealers. But you have a gigafactory and then you ship cars to the dealerships. Then
Hmm.
now you're not shipping cars, but you're shipping microfactories to the dealers.
Yeah.
So
Yeah.
and so this is the another paradigm, another way of scaling. Question is whether a customer should buy a machine or he should outsource.
Hmm. Yeah.
I think both works.
Hmm.
So I've seen both concepts working for the customer. It depends on how they want to play this. If they
Hmm.
want to play it more long term, they need to buy machines. They need to build their own expertise. They
Hmm.
need to They need to go through it, and they need to build internally expertise and culture of working with this technology, and then it will unlock them more capabilities, more possibilities, and more opportunities in future.
Hmm.
So it's a long-term play,
That's a big
but
investment for some people to make
yeah,
too, because it's
yeah,
not just in the
yeah,
machines, it's in the personnel and their education too, because
yes, exactly.
how many strictly 3D printing engineers or 3D printing technicians, those job roles, how many of those exist out in the world today? Very, very few,
Very
relative
few.
to the number of electrical engineers or industrial engineers who are focused on one specific aspect of their part of engineering and their job, right? So, with that being said, do you find that some customers are more so looking to outsource, or are they looking to bring it in-house because they need to invest that time to train their personnel how to use different 3D printers?
I think they do both.
Yeah.
Yeah, so I can't say that it's more this or that. So some customers understand that they want to play it long, so then they invest in buying machines, in learning. Some customers just want to solve. They just want to like these parts, like short-term gain, and yeah, works fine. Yeah, obviously you can always switch from starting with like outsourcing to implementing in-house. So it may be like the first step that you outsource then to prove yourself that this actually works
Hmm.
somehow. But actually I think this is again more the approach of the technology developer. So maybe again I'm looking at it from the technology developer perspective,
Sure.
from my perspective, is
Right.
that how do you want to sell it to your customers? Do you want to sell parts or do you want to sell machines?
Mm-hmm.
Uh, do you want to work with service bureaus or you want to work directly with the customers?
Mm-hmm.
And also both works, but I think that the selling directly to the customers gives much more again long-term advantage for the manufacturer as well,
Mm-hmm.
because you will get much more feedback.
Mm-hmm.
You will get much more pressure, so your own employees will tolerate some imperfections
Sure. Of course.
in the machines you make. They may not tell you that they suffer, and they may get used to it, and they will probably, but the customers will always apply pressure on you if something doesn't work. This will make your technology better. Then
Certainly.
you will learn much more from the customers. You will as soon as the customer get experience with the technology, they will came up with ideas
Mm-hmm.
from their perspective, which is much broader than your own narrow perspective as an OEM. Their perspective is much broader. They may came up with applications you would never think of, but they can only do it if they understand the technology and its capabilities.
Mm-hmm.
So I think it's much more important for the OEM to ship to push it to push the technology into the customer's hands. Much better like learning curve and
Yeah,
stuff.
I was going to say they'd certainly learn a lot more about what is possible
Hmm.
with that particular printer if they have it
Yeah.
in front of them
Hmm.
every day,
Hmm.
and
Yeah.
their employees are pressured to figure it out as well, right? There is that
See?
learning
Yeah.
curve of how do we operate the printer again? How it's not just that magic black box of sending a print
Hmm.
and letting it go, right? But also checking in on that print, seeing how it's doing, learning from how it's actually printing. I think that's been my biggest learning opportunity over the last 10 years now that I've been in the industry is, physically sitting down and watching a print happen and noticing I've got a physics background, a bit of an engineering background, right? So I can tell how the material is behaving as it's being extruded, and I just learned over that 10 years, right, of staring and watching paint dry,
Hmm.
watching filament cool, that oh well, I need to change that one little setting here, or oh, I need to go back to the design and I need to give this a little bit more of a
Hmm. Yeah.
flavor, right? And so those
Hmm.
are the type of things that a customer wouldn't see if they're using a third party to print their parts, right? But
Yeah.
uh,
Yeah. Yeah.
some of that education still has to happen, and that can be a frustrating time though for some customers too, where they just expect it to work when you deliver that machine, right?
Yeah. Yeah.
So,
This
you know,
also happens. Customers can give up, unfortunately.
yeah, well,
But they don't have an unlimited patience, right?
yeah. Well, so how do we
And
bridge that gap though then of giving them enough education of what they need to know to be able to be successful in-house, and in an appropriate amount of time where their bandwidth for focusing on any development work that has to happen is short enough, right? So
this
that,
is one of the biggest problems. This is one of the biggest problems. Uh, we There is not enough people in this world who understand even the basics of what we do.
right.
There's so and there's not enough, o- obviously, to properly teach and explain every customer. That's why it's really important to uh, understand the customer's motivation and
What do you think in particular, maybe, is it more education around design aspects for the type of printing they're doing? Or could it just be the slicer settings? Do we just need to put in more time and effort into making sure that slicer settings are appropriate? But I'll touch on the fact that slicer settings for particular machines and materials could be different for different parts, right?
so
When we talk about
in
the
our
speed,
case,
yeah, and the
in
geometry.
our particular case, it's much more about design.
Yeah.
It's so much more about design compared to most of 3D printing
Hmm.
technologies. So, because here with anisotropic materials, the you your design is not just the geometry. Yeah.
Hmm.
So for isotropic materials, the design and geometry are synonyms, almost synonyms, right?
Right.
For anisotropic materials, you have geometry and you have internal structure.
Hmm.
So same geometry in you can have fibers put in a different directions in every point, and this will give completely different results. So when you have anisotropic materials, you are not only designing the geometry, but you also designing the internal uh, material structure.
Hmm.
And this is something that uh, very hard to. This is a hard thing to understand and to learn.
Hmm.
And this is not really taught in schools.
Hmm.
You may have some understanding if you're a good engineer from a good school what mechanics of materials is, what anisotropy is, what is a stress tensor, or what are the principal stresses, and that's how they are like oriented, and what are the stress states, and what is the difference between compression and tension and bending and directions of these force of these internal forces. Uh, but it really becomes much more complicated when you have to consider uh, material anisotropy.
Hmm.
Uh, and the probably the solution here is that we should exclude uh, human from the equation.
Right.
Yeah, so you should at least you should get the initial guess, like the initial iteration done by machine.
Hmm.
Uh, Otherwise, the 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 human's first guess will be so much off. Uh,
Right.
and it's not. I've seen it's like aerospace engineers, professionals who work in the industry for decades, it's still hard for them to get over this concept.
Hmm.
Uh, Even though they've been working with composite materials, but they still used to work with QI, as they call quasi-isotropic laminates mostly,
Hmm.
which basically were invented to eliminate this complexity in
Hmm.
composites and to make engineers' life easier. They've
Sure.
invented this
Sure.
QI to eliminate this additional freedom, which in the end killed all the advantages and killed all the beauty of composites, because all the beauty
Hmm.
of composites is in this directionality. The composites are only good because they are directional. And
Hmm.
if you
Hmm.
have the thing that is only good because it's naturally the properties, the high properties of carbon fiber. Yes, if we start with the carbon fiber, it's highly directional, highly oriented carbon molecular chains. they are stretched to be highly oriented.
Right.
So and by orienting, what you do is you focus the material density in a certain direction. You get all the material properties, all its density, and stretch it and focus it in one direction. This is why it makes it so high. So these high properties comes from the fact that they are directional. And then after all, you say we just ignore it and direction indifferent again, then you dissolve back all the properties and you get the material which is actually not good. So
Mm-hmm.
UD carbon, like the classic aerospace UD carbon is 2.4 GPa strength
Mm-hmm.
in fiber direction, but QI is 300 MPa, so eight times of 8 times lower strength
Yeah.
of the QI compared to the UD.
Mm.
Uh, and this is killing all the advantages. So for anisotropic materials, it is necessary to take it into it's not necessary, it's the only option if you want to get any value.
Right.
You must dig into this complicated uh, material science to be able to benefit. And it's complex, it's hard, but this is where the gold is. Easier use cases, easier geometries when we talk about anisotropy is kind of like one-dimensional parts,
Mm-hmm.
which so the parts that has one side is like much longer than the other sides, and in these cases your forces will be also mostly one directional. Yeah, and so imagine kind of rods, right? Rods or beams or
Mm-hmm.
connectors, uh, and normally these kind of um, parts you can make them with the traditional kind of composites with pultruded or like with the tubes, right? The carbon tubes.
Right.
But if you have hinges, if you have a rod with uh, hinges, then which works in tension, yeah, you cannot make it with a uh, with a rod because you will
Mm-hmm.
have to glue metal
Mm-hmm.
parts. And with 3D printing, you can wrap the fiber
Mm-hmm.
around the hole in these hinges, and then you have the smooth transition of stresses. And these parts are quite frequent in like aerospace,
Mm-hmm.
these kind of beams, and we have projects on that which are very simple to understand and to illustrate the the value. Uh, but but if you talk about like real aerospace, then you have the problem of certification and stuff. So
Sure.
then you have less regulated uh, applications with drones, UAVs, unmanned
Mm-hmm.
stuff, which are less regulated. And this type of simple parts, simple use cases, yeah, it's not only aerospace. You can see it in sport cars,
Mm-hmm.
like suspension arms. You can see it in robotics. Like these are the applications which do not require too much design for additive manufacturing. It does
Right.
require, but it's rather simple and it's easy to explain and it's easy to understand. It's easy
Hmm.
to illustrate. What we are aiming for actually for composites, obviously, it's larger structures. The main advantage, the main type of structures where composites would uh, work best are actually frames and trusses.
Hmm.
So imagine like a, mm, a car frame as a truss structure,
Sure.
uh, a spatial frame made of these beams, because this is where composites, contrary to uh, laminates, right, where you have to dissolve the properties in all planar directions. If
Right.
you have a truss like structure which is made with beams, then in each beam the stress strain state is simple 1D. So the forces in the beam are only along the axis of the beam.
Hmm.
So if your fiber then is also along the beam, so the composite material only works along the fiber.
Right.
Uh, but then the you have this problem of links. How do you handle crossings and links?
Right.
Um, uh, and how do you do it in actual like 3D space?
Right.
Uh,
Yeah. Are those separate parts that you're printing,
yeah,
together, or would there be a
yeah,
way to then
exactly.
design it
Yeah.
in a different way where
Mm,
they could work, all as one joint piece, and then
mhm,
having
mhm.
the printer be able to physically print something like that?
Yeah, yeah. So basically, the small machines are just the first steps,
Hmm.
and the we intentionally we were thinking that because our first prototypes were actually robotic based, like on the big robots,
Yeah.
and because this is what customers wanted, and they still want it, and they wanted it 10 years ago, they still want it.
Yeah. Yeah.
But we realized that there are too many unknowns, too many difficulties uh, uh, going from 2.5 2D to 3D is a big thing, as in especially for software.
Hmm.
Scaling the size is also a challenge. So we thought that you first need to do something that works, even though if there is no huge market,
Hmm.
and if there is some market you can build upon, you can scale upon, you can learn with, then it's already doing it like step by step. But
Right. It's that
the
maturing of the
ultimate,
additive
yeah,
manufacturing industry too, It's not
yeah,
just the
yeah,
maturing of the educational standpoint of our customers, but then the
yeah,
maturing of our
exactly.
understanding of the technology too, and how best to approach some of these, examples that some customers are coming to us with. Again, I really enjoy what I do because every day there's something different. You've got different people trying to solve different problems, and they're all thinking about it a slightly different way. And again, with some tolerance levels or no tolerance for, the amount of development time that it takes to come up with a truly viable solution for them, right? And
Yeah,
I just
exactly.
wanted to kind of highlight that, there's still a lot more to be done, I think, from an additive manufacturing industry standpoint of delivering these more, like we talked about earlier, these more targeted solutions for people's problems, right? I know that's been kind of touched on in the industry as a whole, where some of these 3D printing concepts are more solutions looking for a problem, whereas
Mhm.
we need to then flip it and really
Yeah,
consider the problems that people are having and
yeah,
developing solutions for them.
yeah, and this is the thing. Yeah, so people, uh, customers, they may not know that there is a solution for their problem, so it's hard for them to imagine that how this solution would look like, and no one can explain this to them.
Hmm.
No, it's hard for them to visualize, and if it's hard to visualize, it's impossible to find when you don't know what it looks like, what you're
Right.
looking for. Uh, and this means that we should show we we should focus on uh, helping that helping the because we are not we are additive manufacturing is what they call how they call it supportive, right, technology. Yeah, so
Right.
um,
Yeah.
uh, uh, we're just here to help others make products for customers.
Right. Well, again, our
uh,
hope being in the industry is that it goes one step further than just being supportive, but being, the dependent upon technology in order to produce that item true, right? And
yeah,
again, it's
surely.
that whole process of development going from the magic box idea that we talked about at the beginning, and now kind of coming full circle to no, we really need to understand everything that's involved with the design for additive manufacturing concepts and considerations that we need to take and truly come up
So
with a suitable result for that purpose.
obviously, additive manufacturing is a new domain of manufacturing technologies, right? It deserves to have a big chunk of the whole pie, right? Of the whole manufacturing pie because it has a clear advantages compared to the traditional, like well-established technologies like injection. You can name injection molding, CNC machining, sheet metal forming, uh, whatever is there. Yeah, like extrusion, like whatever, right? Uh, and it this if an additive manufacturing uh, would be like a similar size to any of these, right? It will be good. It will be good enough for us OEMs. Yeah, it's a big market,
Right.
and but it's still much smaller compared to these uh, technology domains. If it can
Absolutely.
reach up to the size and with its unique value propositions, its unique applications, its unique features. This is what we want, and we still have a lot job to be done to get there, right?
Right. Yeah, and I think it's a two-way street too. It's not just on us, but again, this relationship we have with some of our customers to ensure that, they are really going down the right path with their thought process and making
Mhm.
sure that, we can deliver some of these solutions to them. And it's a collaboration, right? It's working together with them to understand their needs and then come forward with a solution that will work, whether it's a micro factory or a gigafactory or working with a third party, right? But no,
Yeah.
I mean thank you, Fedor, for all these insights today. This has been really, truly insightful, and just an opportunity for us to realize kind of what all is involved with not only continuous fiber printing like you're doing at Anisoprint, but just in fact of, going from a bamboo printer or any other desktop printer to then a large format machine or robotic printing. There are so many different little considerations that we need to take into account here that I'm really appreciative of this time with you today to kind of demonstrate what really goes into all of this for some of our customers. So yeah, thank you for that time.
Thank you, Joe. Really
Yeah,
enjoyed the conversation.
yeah.
Thanks, everyone.
I hope everyone got a lot out of this episode of the Fabrication Friday podcast. There's a lot more to be said on how design for additive manufacturing can truly help your product. So, reach out to either of us here to continue discussing this more. Fedor, like we said earlier, I think we could talk on hours here for this topic, but for today, we will leave you with a little bit more thought and processing that you'll go back to the drawing board now for your engineering team on some of these designs and take some of these considerations into account. But thank you everyone for listening to the Fabrication Friday podcast, and happy printing.